Welcome to our presentation and thanks for watching. If it is your first time, please kindly subscribe for more videos. In this presentation, we are going to talk of the minimum and maximum values of quadratic expression, or can call them minima and maxima. So we are saying that when a quadratic equation whereby it is in the form of ax squared plus bx plus c equals to 0 is graphically represented by plotting some values in form xy in the Cartesian plane, then the curve or the parabola formed, domain number 1, curves upwards, or we can say forms a trough. And in here we are saying such an equation or such a graph or a parabola is having a minimum or a minimum value, which is the same as a minimum. So we can now see this graph. It is curving upward, like the way you see, curving upward like this. So in here we have the minimum point is at extreme, the lower extreme, where the curve or the parabola turns. Then domain number 2, we are saying that curves downward or forms a peak. And when it forms a peak, then it is having a maximum value or a maximum. And when you look at this graph or curve, rather the parabola, it curves, as you can see, thereby forming a maxima at this point here, and it can be called maximum value or maxima of that very graph or the quadratic equation whose parabola has been presented graphically. So we have two conditions in here. We have domain number 1. So let's look at domain number 1. The quadratic expression ax squared plus bx plus c has a minimum value or curves upwards. So the condition here is that the value of our coefficient on x squared, which is a, should be greater than 0. So we should not forget that if the value of a in a given quadratic expression or equation is greater than 0, then the graph of that expression, quadratic expression, forms a minimum or has a minimum value. Whereas for domain number 2, when we have a quadratic expression still plus c, this equation is to have a maximum value if and only if the value of a is less than 0. We can have examples here, and these examples we are going to determine the minimum or the maximum values of the quadratic equations and also state when they occur. So we are going to say we have 1, determine the minimum or maximum values of the following quadratic expressions or equations and state when it occurs. So we are going to have part A. So we can have x squared plus 4x minus 3. Then part B, we can have 5 plus 2x minus x squared. Then part C, we can have 2x squared plus 3x plus 1. Then part D, we can have 3 minus 2x minus x squared. So we can have our responses, say part A. So in part A, from part A, we are having our quadratic expression as x squared plus 4x minus 3. So in here, as we compare this quadratic expression with, so we are comparing it with the ax squared plus bx plus c. So this implies that our a equals to 1, our b equals to 4, and our c equals to negative 3. And we are starting from x equals to negative b divided by 2a. So let's now get the value of x. It means that our x is going to be equal to negative 4 because our value of b is 4 divided by 2 multiplied by our value of a, which is 1. So we are getting our x equaling to negative 4 divided by 2. So we have x equals to, as we divide, we are getting negative 2 as the value of x. Then from here, to get the value of y, we are just going to simply let y be equal to our quadratic expression, which is x squared plus 4x minus 3. Then here, we are going to substitute in the value of x. We have got the value of x being equal to negative 2. So what we are going to do, we are going to substitute in. So this implies that y equals to, we substitute in negative 2 but squared plus 4 into the negative 2 minus 3. So our y equals to 4 minus 8 minus 3. So our y equals to negative 7. We can now conclude therefore minimum value of the equation x squared plus 4x minus 3 is negative 7, and it occurs when x equals to negative 2. Then we can try out part B. We can go to part B. So part B, we have 5 plus 2x minus x. So part B, we have 5 plus 2x minus x squared. In the same way, by comparing this with the general form of the quadratic expression, we see that our value of a equals to negative 1, our value of b equals to 2, and our value of c equals to 5. And then we are saying that from x equaling to negative b divided by 2a, it implies that our x is equal to negative, but our b is 2 divided by the 2 times our a, which is negative 1. So here we are having x equaling to the negative 2 divided by negative 2. So our value of x equals to a positive 1. So from here we can now let y equals to the 5 plus the 2x minus x squared. So by substituting the value of x, we are going to have 5 plus the 2 multiplied by x, which is a 1, minus the x squared, which is now 1 squared. As we simplify this, we have y equals to 5 plus 2 minus 1. Our y equals to 6. We can now conclude. So conclusion, therefore, the maximum value of the expression 5 plus 2x minus x squared is 6, and it occurs when x equals to 1. We can now try out part B and also part D. And please drop the answers in the comment section.